Alright, so we are on page 33 in our textbook. It's lesson 2, session 4. Juan draws triangle A in the coordinate plane. He uses a single transformation to form the image of triangle A. Important pieces of information is he drew A, and then he's using a single transformation to find A prime. One of y'all go erase my board for me. And then, so what is the single transformation? That's what we're trying to find out. So there's actually three transformations. Sorry. All right, there's 3 transformations that can happen. Pause now and write those 3. All right, so we said that it could be a reflection across the y-axis. So reflection across the y-axis. We said that it could be a rotation, and we could rotate it 90 degrees clockwise about the origin. We also said that it could be a rotation of 270 degrees counterclockwise about the origin. Alright, so our center of rotation is here. We could have rotated it 90 degrees to get this same triangle, or we could have rotated it 90, 180, 270 to get that triangle. Alright, so normally, guys, you can't pick 3 different transformations for this. Why is it that in this problem we can pick 3 different transformations? What's different about this that we've not had in the other ones? What's not there? So here, what's not here? Okay, not the coordinates, but the what? No, the origin's right there. What are these not? What are these points called? Vertices. The vertices are not what? They're there. They're just not labeled, right? They're calling this whole thing triangle A and the image of triangle A, but they're not saying which point goes with this. So if they labeled the points, it's going to give us one transformation because you're going to have to find the corresponding angles. Here, there's only one that you can tell for sure, and that's the 90-degree angle, right? The rest of them, it could be either because they're the same. All right, flip the page. All right, so here it just shows you this one by itself. So it shows you the line of reflection. It shows you that it was flipped across the line of reflection. It's a mirror image. And then here it shows you that it could be rotated 90 degrees clockwise, or you could have gone 90, 180, 270. Okay? You could have done either of those. All right, looking on page 35. We kind of already talked about this, but it says, look at both modelets. Why is it important to tell whether one used a reflection or why is it impossible to tell whether one used a reflection or a rotation just by looking at the image? We just talked about it. That's your hint. Why is it impossible to tell? What's not there? The vertices are not labeled. All right. In number 2, it says triangle A is shown with its vertices labeled X, Y, and Z. So now we have labels. In this first one, it wants you to show the image of it as a reflection. So go ahead and do that now. We're reflecting it across the y-axis. Label x prime, y prime, and z prime. Okay, so we're reflecting it here. Label it x, y, and z prime on this side. You have 3 letters. Write 3 letters down. If you get it wrong, you have an eraser and you can fix it. Don't sit there and do nothing. Z's here, Y, and X. You got to label them over here. What is the easiest one to point out? That's what everybody has been saying, but to me, it's not X that's the easiest to point out. It's Y, because Y is in this right angle right here, right? So when you come over here and look at this one, where's the right angle at? Right here, so what is this one going to be? This is Y prime. Alright, so which one did you say was X prime? The one at the top, right? It's 1 away here, so it's going to be 1 away here. So this is X prime, and then Z is 3 away, so it'll be 3 away here, so that is Z prime. Alright, so now we're doing a rotation. The origin is the center of rotation, and we're going to rotate it 90 degrees clockwise. Label the vertices. Don't just sit there, label them. Again, which one is the easiest one to tell what it is? Y. Because it's the right angle, right? So that one is definitely Y prime. If I take this image and I spin it, look guys, I'm taking this image and I'm spinning it around, where is X going to be at when I spin it? Right, the one on the bottom down here. So this is X prime. I took it and I spun it. X goes to the bottom, and then Z is up here, right? So now in problem 2, we're looking at number 3 now. It says in problem 2, you can tell whether a reflection or a rotation was used to transform XYZ by looking at the image. Explain. So can you tell whether it was a reflection or a rotation now? Yes, then why can you? The vertices are labeled you can look for corresponding vertices, period. Right, number 4. How do labeled vertices help you identify which transformation was used to transform a figure? So, how can we tell? We can look for what? Yes, somebody said it. Corresponding angles. We can look for the corresponding angles. And we can look at the location and orientation, right? So look at the location and orientation of the corresponding, I'm pretty sure I spelled that wrong. Oh well. right, turn the page. Number 6, it says, Brett and Sophia each perform a single transformation on figure JKLM to form the image. Brett translates. So Brett translates up 4 units. So this is Brett right here. He translates it up 4 units. We are going to label the vertices of each student's image. So we are going to label JKLM is here. He's translating it 4 units up. So you label where the vertices will be for the image. Each point will be translated 4 units up. So you're going to write J prime, K prime, L prime, and M prime. Translated 4 units up. All right, 4 units up. So that means at this point here, J has to go up 4 units. So 1, 2, 3, 4. So that means that J prime should be there. Is that where you put it? K, up 4 units. 1, 2, 3, 4. M, up 4 units. 1, 2, 3, 4. M is here. L, up 4. 1, 2, 3, 4. Alright, then it says that Sophia rotates it 90 degrees counterclockwise around the origin. So she's taking this image and she's going to turn it 90 degrees. Okay? So she's taking this image, turning it 90 degrees. Write J prime, K prime, L prime, and M prime. You have to write 4 letters. If you get it wrong, you can erase it. Nope, it's not in the box. It's all right. So, where was J prime when we rotated it 90 degrees? Say it. Where is it? Top or bottom? Left or right? So J prime would be here. Look, we took it and we rotated it 90 degrees. So we're spinning this image 90 degrees. So where is K prime? Top. Where is L prime? And then where is M prime? All right. B says, what is another single transformation you could perform on figure JKLM? Label the vertices of the image to show your transformation. So there's one more that we can do. We translated it, we rotated it. What else can we do? Well, you could, but there's another one. Reflect. So we're going to reflect across what? The x-axis. So here is our line of reflection, reflected across the x-axis. Okay, and label the vertices. So label J, K, L, and M prime. Alright, where is J at when we reflect it? Bottom left. If it's one away here from the line of reflection, it's one away here. What about K? Okay, L is 3 away, so it'll be 3 away here. And M is 3 away, so it'll be 3 away here. Right, number 7, it says Rosa transforms figure PQRS to form P prime, Q prime, R prime, S prime. Label the vertices and tell what single transformation Rosa used. So we're telling what the single transformation is, we're labeling it. Those are the first 2 things you need to do. And then, is there any other transformation you could do? Okay, what is the transformation? And label the new vertices. Do that now. Alright, who's going to tell me what it was? Eli. Translate 4 units left. Alright? Write the new units, or the new labels. PQRS prime. So if it's translating 4 units left, that means that P goes 4 to the left. 1, 2, 3, 4. P prime. Make sure you have QR and S. Q, 4 to the left. 1, 2, 3, 4. R, 4 to the left. 1, 2, 3, 4. S, 4 to the left. 1, 2, 3, 4. Alright, so the next part says, is there any other single transformation that could have been done? Explain. So is there another single transformation that could happen to give us this image? Did the orientation change? Short side is on the right. When I go here, is short side still on the right? So did the orientation change? No. What is the only transformation that doesn't change the orientation? Translation. So is there another one? No. The orientation did not change. Alright, last problem here. It says, Andre transforms A, B, C, D, E, F to form its image. A prime, B prime, C prime, D prime, E prime, F prime. What single transformation did he use, and how do you know? So how did he go from here to here? Is it a translation, though? A in this one is on the left. In this one, it's on the right. So the orientation changed, so it's not translation. Is that what you think it is? Rotation? All right, well, if I rotated it, I think that A would be down here, right? So it's a reflection. And what's the line of reflection? Y-axis. The y-axis. Okay, and then how do you know? So what are reasons that we know? First off, we said what changed. What was the first thing we talked about? The orientation changed. Okay, and what else did we know? If we folded the paper, would the vertices line up? Yes or no? If I folded this paper, yes. Would the vertices line up at the line of reflection? So if you fold the paper at the line of reflection, the vertices line up. That is also called a mirror image. Alright, so you need to make sure you have all of this down in your notes. If you've been absent, there are videos to go along with everything that we've done. So you can catch up on all the notes from the book. We've done almost all of the pages 1 to 36 at this point. You have homework tonight. It's page 37 and 38, so you can go ahead and tear that out and put your name on it. It will be turned in tomorrow. Use the rest of the time that you have now in class to complete that.